there! In the following video I will show you how to answer question 8 of the January 2009 Core 4 OCR paper. Again, this is my fourth video on implicit differentiation questions. Let's take a look. Here's a curve defined to you implicitly, okay? And it asks you for dy by dx in terms of x and y. So let's do that. Part 1. I'm going to differentiate everything with respect to x. Okay, so I'm going to take the derivative with respect to x of x cubed, and I know that's equal to 3x squared. I'm going to take the derivative with respect to x of y cubed. Okay, that is the same as taking the derivative of y cubed with respect to y. Okay, and then correcting by post multiplying by dy by dx, and this would give me the answer 3y squared dy by dx. So this is 3y squared dy by dx. Okay, and I'm also going to differentiate 6xy. Now, how I'm going to do that is using the product rule. I'm going to think of u as 6x and y as 6x as u and y as v, and use what's the product rule, which tells me the differential of that is uv dash plus vu dash. Okay, so I'm going to differentiate that, keep my u as is, 6x, differentiate y with respect to x is simply dy by dx. Okay, and then I'm going to have plus y, and differentiate the 6x with respect to x, I get 6. So tidying that up, I would get 6x dy by dx plus 6y. Okay, now I know the differential of this plus the differential of this is equal to the differential of this. So let's write that down. 3x squared plus 3y squared dy by dx, so 3y squared dy by dx must equal 6x dy by dx plus 6y. Okay, that's just writing this equation here having been differentiated. Now I'm going to collect all the dy by dx's on one side and collect everything else on the other. So doing this in one move, if I had dy by dx left on this side, I've got 3y squared of them, 3y squared. I've got subtract 6x of them, okay? And on this side I would have 6y subtract 3x squared, 3x squared. Okay, and then making dy by dx the subject of the formula, dy by dx would therefore equal 6y minus 3x squared, all divided by 3y squared minus 6x. Okay, so we've got dy by dx in terms of x and y as required. Okay, part 2 then asks us to show that these coordinates lie on the curve and dy by dx at this point is 0. Okay, well let's do the easy part first, show that this lies on the curve. So let's take 2 to the 4 over 3 and we're going to cube it. And we're going to take 2 plus 2 to the 5 over 3 and we're going to cube that as well. So the power of the power rule means you can multiply powers. So this is the same as 2 to the 4 plus 2 to the 5, okay, which if you tap it in your calculator, 2 to the 4 is 16, 2 to the 5 is 32, you get the answer 48 for this, okay? Now, let's work out what 6xy would be. Well, it would be 6 times 2 to the 4 thirds times 2 to the 5 thirds. Now, if the base numbers are the same, you can add the powers. So 2 to the 4 thirds add 2 to the 5 thirds is 2 to the 9 thirds, which is 2 to the 3. So this is 6 times 2 to the power of 3. Well, 2 to the power of 3 is 8, and 6 times 8 is 48. Okay, so therefore this lies on the curve. Let's check what dy by dx is at this point. Well, we know that dy by dx was given by a formula we worked out on the previous page. Dy by dx was 6y minus 3x squared, so it's a 6y minus 3x squared divided by 3y squared minus 6y, so 3y squared minus 6y, sorry, 3y squared minus 6x. Now, the only way this thing can be 0 if the top is 0, okay? That's the only way this can be 0. So all we need to check is whether the top or the numerator is 0. So 6, okay, times y is 2 to the 5/3 minus 3 times 2 to the 4/3 squared, okay? So let's work that out. Well, just tidying that up, 1/9, that's 6 to the 2 to the 5/3 minus 3. The power of the power, you can times these, so that's times 2 to the 8/3. Okay, and if you work that out on your calculator, 6 times 2 to the power of 5/3 minus 3 times 2 to the power of 8/3 you get 0 as required. You get 0 as required. Okay, so dy by dx is 0 at that point. Okay, lastly now, it asks us the point AA, where A is bigger than 0, lies on the curve. Find the value of A and the gradient of the curve at this point. So it's rather simple. You know that AA lies on the curve, so you know that if you put x is A and y is A into this, it satisfies this equation, so you get A cubed plus A cubed must equal 6a times A, so that's in particular 2a cubed equals 6a squared. Okay, dividing everything by 2, you get a cubed is equal to 3a squared. Subtracting 3a squared, you get a cubed minus 3a squared is 0. Factorising out a squared, you would get a squared, a minus 3 is 0. So a is either 0, which you're told to ignore, or a is 3. Okay, so a must be 3 at this point, so the coordinates are 3, 3. And what's the gradient of the curve at this point? Well, all you've got to do is substitute in x is 3 and y is 3 into your dy by dx. So what was your dy by dx again? Your dy by dx, going back to the original, was 6y minus 3x squared. So 6y minus 3x squared, all divided by 3y squared minus, so 3y squared minus 6x. You sub in 3 and 3 into this, so 6 times 3 is 18. X squared would be 9. 3 times 9 would be 27, so take away 27. Y squared would be 9. 3 times y is 27, and 6 times 3 is 18. Okay, so if you do that, you would get 18 minus 27. You would get minus 9 over 9, which would be minus 1. So the gradient of the curve at this point AA, i.e. 3, 3, is minus 1. I hope you found this useful going through question 8 on implicit differentiation. Thank you for watching.